Hey guys, my name is Emily.
Hi, my name is Kate Johnson, and we did our experiment on the effects that artificial sweetener have on insulin resistance and sensitivity.
So, artificial sweeteners are sugar substitutes that are added to food and drinks. Insulin is a peptide hormone that maintains blood glucose levels through various functions. Those functions are controlling cellular glucose uptake, regulating carbohydrate, lipid, and protein metabolism, as well as promoting cell division and growth. Insulin resistance is when the body does not respond well to insulin and results in elevated glucose levels in the blood. And from our article we used, they found that ingesting artificial sweeteners causes the pancreas to release insulin that is mistaken for glucose. This process leads to an increase in the levels of insulin in the blood, which causes a decrease in receptor activity because of insulin resistance. And from these findings, we asked ourselves, is there a significant difference in insulin resistance between people who use artificial sweeteners like sucralose and people who use regular sugar like glucose?
We did a lot of background information on how chronic sucralose consumption induces the elevation of insulin in young, healthy adults. And this is a figure that we found that supported our our experiment. And so in graph A, you can see the average glucose levels of both the control group and those treated with the sucralose. And graph B shows the average insulin levels of the control group and those treated with the sucralose. So in the dark gray, you have week 0, and the light gray, you have week 10. So you can compare when they first started the treatment versus at the last week, which would be week 10. So the glucose and insulin concentrations in the individuals taking the placebo, or so the control group, were similar when comparing week 0 to week 10. However, the volunteers receiving the sucralose concentration had higher glucose and insulin levels than those found in controls receiving placebo. Additionally, those taking the sucralose, their levels increased significantly from week 0 to week 10 in insulin and glucose. So basically, this data is suggesting that chronic consumption of sucralose, which is an artificial sweetener, reduces the insulin sensitivity. So in consequence, insulin production tended to increase with the aim of keeping glucose levels in their normal values. And that's what you can see as the bars increase for the sucralose treatment group.
For our experiment, we hypothesized that if a person uses sucralose, then they will be more resistant to insulin than someone who uses glucose. Our null hypothesis was that there is no significant difference between people's insulin resistance and what type of sugar they use. We then predicted that people who use sucralose will be more resistant to insulin, whereas people who use glucose will not.
For our experiment, all of the participants that we will gather will be healthy individuals between the ages of 20 and 35 with no history of insulin resistance or diabetes, and the amount of natural sugar they consume daily will be within the recommended daily intake, which is about 24 grams. So we will have 3 different experimental groups. One group of 40 people who will be given 48 milligrams of sucralose, which is an artificial sweetener. One group of 40 individuals given 48 milligrams of glucose, which is a natural sugar. And then the last experimental group will also contain 40 people who will be given water as a placebo, and that will be our control group. In each group, we will measure their fasting blood glucose levels and their serum insulin after the administration of the sucralose, glucose, or water. We will measure this using the HOMA-IR calculation, and the 2 measurements we gathered will be able to be plugged into that equation to give us the individual's insulin resistance. So the scale for the insulin resistance from the HOMA-IR calculation will be a normal insulin resistance will be below 3, moderate insulin resistance will be from 3 to 5, and severe insulin resistance will be above 5. Each participant will be given their treatment once a week for 10 weeks, and we will measure their insulin resistance 15 minutes after each administration.
For our experimental process, we first want to gather a sample of 120 participants, and then we're going to administer dose of treatment to each group. We will have 40 that get the water placebo, 40 that get the sucralose, and another 40 that get glucose, with our water placebo acting as our control. And in order to obtain our measurements, we are going to measure each week for a total of 10 weeks. And to analyze our results, we will then place them in an Excel sheet.
These are our results that support our hypothesis. On the x-axis, we have the week of treatment. On the y-axis, we have the insulin resistance in milligrams per deciliter. And you can see all three of our experimental groups. Dark purple being the glucose treatment, orange being the sucralose treatment, and pink being the water placebo treatment. As you can see, over time, each week, the group who was given the sucralose treatments, their insulin resistance continues to rise. Glucose, you see a small rise, but not anything significant. Our p-value was 0.0024 when comparing the sucralose and the glucose treatment on week 7. You can see with an asterisk which ones we put in the t-test. And that p-value is less than 0.05, so it tells us that our data was statistically significant. And because of that, we can reject our null hypothesis that our data is not statistically significant. These are the results that reject our hypothesis. On the x-axis, you can see the week of treatment. On the y-axis, you can see the insulin resistance, and that's measured in milligrams per deciliter. You can see each of our 3 treatment groups. In dark purple, you have the glucose treatment group. Orange, you have sucralose, and pink, you have the water placebo treatment group. Our p-value that we collected from taking a t-test on week 5's glucose treatment group versus the sucralose treatment group was 0.067, which is greater than 0.05, so that indicates that our results are not significantly different, and they could have happened by random chance. So because of that, we will accept our null hypothesis that the treatment groups and the results are not statistically significant. For the results that supported our hypothesis, our p-value was less than 0.05, which means that our data is statistically significant. These results show that those who were given the sucralose, which was the artificial sweetener, will have a higher insulin resistance than those who were given the same amount of glucose, which is a natural sugar. This supports our hypothesis, and we can reject our null hypothesis that there is no significant difference. The results that rejected our hypothesis, on the other hand, the p-value was greater than 0.05, which meant that there is no significant difference between the group who received the sucralose artificial sweetener treatment versus the group who received the glucose natural sugar treatment. Because of this p-value, our data is statistically insignificant, which means that we must accept our null hypothesis.
When thinking about our potential findings, if we relate it back to our background, it makes sense that those who consume sucralose develop a higher insulin resistance than those who consume glucose. And if our hypothesis were to be supported, it would provide even more evidence that artificial sweeteners should not be used in foods or beverages. Biologically, it would mean that the human body is not meant to intake artificially sweetened substances, and the more those substances are consumed, the greater one's health can decline. Overall, our research would add to what is already known about the relationship between artificial sweeteners and insulin resistance. So here are the sources we used, and we hope you enjoyed our presentation. Thank you.